Short duration induced AC withstand voltage test. Okay, induced over voltage test. So the objective with this test secure the insulation between the phase winding, turns, coils, tapping leads, and terminals withstand temporary over voltage which transformer may be subjected during its lifetime. So the procedure, alternating voltage as close as possible, 2 times the nominal voltage. As you can see in the rating, guys, there is U, that is our nominal voltage, and 2 times, okay, of the nominal voltage shall be applied to the terminal of the one winding of the transformer. Okay, and then another other winding of leftover circuit duration test in seconds shall be 120 times of the rated frequency divided to test frequency not less than 15 seconds. So about the typical acceptance criteria, so successful is collapse, okay, the same, and then mistakes, always the same mistakes, and then instrument equipment use, power analyzer, digital multimeter, elevator transformer, rigidity tester, and voltage transformer. So this is our example of equipment. So power analyzer, as you can see that one, that is our power analyzer, and then this is our voltage and current transformer during our testing. Okay, so measure of no load losses and current. So we have another testing as well. So this is our the purpose of this measurement of no load losses and no load transformer, rated voltage and rated frequency. So procedure, so you can see that one. So winding rated frequency, transformer should be approximately factory ambient temperature. Just follow that one. Typical acceptance criteria. And then no load losses exceed the maximum expected value plus 10% of guaranteed value and 15% plus of total losses guaranteed value. So no load current shall not exceed the maximum expected value of positive 30% guaranteed value. So typical mistakes, bad wave shape of feeding voltage, wrong range of instrument use, wrong wave shape corrections, and then this is our equipment instrument. Okay, current transformer, voltage transformer, power analyzer, and elevator transformer. So example of this equipment, okay, typical no load curve. So measure of short circuit impedance. So this is the purpose of the measure impedance, and then this is also our procedure, 25% to 100% of the rated current according to the standard. So you're always basing the standard, and then the typical criteria that is increases plus positive 15%, and then plus 10% total value, total losses guaranteed value, and then here the no load current that is negative 20%. Of course, our typical mistakes and instrument equipment to be used. So this is example test result. So for IEC insulation class NEMA maximum rise temperature, this is the table. As you can see, from IEC 685, and then NEMA class, UL letter, maximum allowed spot temperature, maximum permissible rise temperature, then self-evaluation test, guys. So now, so far, we already know those of the testing, whatever, what is the standards and other things. So now we need to test ourselves. This measurement is carried out to determine the load losses of the load of the transformer and the impedance voltage at rated frequency and rated current. The load losses are used to calculate the transformer efficiency. So what is your answer? Measurement of short circuit impedance and load losses. That's the answer. And then this measure is carried out in order to test if insulations between the windings and the insulations between windings and earth parts withstand the temporary overvoltages which may occur during service. Again, what is your answer? Applied voltage test. Okay, and then the purpose of to check that the temperature rises of the active part of the transformer oil windings core do not exceed the limits agreed or by the standards. Of course, the answer is temperature rise test. So another, why tests on transformer should be performed at no load and full load condition. So this is the questions, guys. A, to review characteristic according data sheets, calculate the different losses efficiency calculations, review safety parameters, all of the above, none of the above. Of course, you can see there the D, all of the above. Tests on the transformer should be performed at no load and full load conditions. Always remember that. To review characteristic according data sheets, to calculate the different losses for efficiency calculations, to check the safety parameters. So what are the different losses to be measured for efficiency calculations? There are 4 answers in that. So A, Joule losses, hysteresis losses, eddy current losses, stray losses. Okay? So the minimum duration of applied voltage for the induced over voltage test for a 60 Hz transformer, considering the way apply the 150 Hz voltage, is 60 seconds, 48 seconds, or 120 seconds. What is your answer, guys? Of course, maybe you're thinking 60 seconds, right? The answer is 48 seconds. So the temperature rise test stops when the balance is reached when primary column temperature rise has become steady or winding temperatures increase usually. What is the answer? Less than 2 K per hour. Okay? So temperature rise steps up the balance of reached when primary column temperature rise has become steady or winding temperature increase usually less than 2 Kelvin per hour. Okay, degree Kelvin per hour. The efficiency of a transformer is. What is your answer? Very clear. Letter B, power input, that is W over P, equal electric power output from the transformer, that is watts. So, okay, power out, power in. So that's it, guys. Thank you very much, and thank you for all your support. Continue watching, and those who are new in my YouTube channel, don't forget to like and subscribe and share to your colleagues so that they will know also some of the informations related inspection, testings, guidance for related of the transformers. And I have so many videos related of my works, engineering, and constructions, quality inspections, and other things. Thank you and have a nice day. God bless all.